Hi everybody, in this video we are going to begin doing a bunch of videos on solving trig equations. We're going to have a bunch of different methods, going to blend it in so you can see a little bit of everything and a variety of directions. So you want to pay really good attention to what the directions are asking you to do in each scenario because that affects things. A big question that we get a lot is, when do I use plus 2 pi n? Because at first I might think like, oh, I only use it when I'm finding all solutions, and that can be the case. However, we could also use it when we're finding multiple solutions. Multiple is the keyword here. When we have something called a multiple angle. And a multiple angle is when you have cosine, where this is cosine x, it would be something like cosine 3x or cosine x over 2 or cosine x plus pi over 3, something like that. Once your little cocoon that the x lives in is more than just x, right? It's got company inside its little house. We gotta look at the multiple angles, and I'm gonna try to demonstrate with graphs at the same time. I'm gonna pull some Desmos on the screen. So let's get going on this. So the directions here ask us to solve each trigonometric equation between 0 and 2 pi. So we're going to solve in radians. Even if it didn't say the little phrase right there, in radians, you still have to solve it in radians because it says 0 to 2 pi. If it says 0 to 360, then that's a different question, of course. But it says from 0 to 2 pi, it's implying radians, so we will give answers in radians. When it says between 0 and 360, we'll give the answers in degrees, and so on. Okay, sorry, I just need to fix what I'm looking at on the screen so I can read a little better. All right, so in this example, what we want to do is we want to get cosine x alone the way you would normally want to get x alone. The hint here even says to combine like terms. I'm going to add cosine x, you could call it cosine theta if you prefer, to both sides. So I'm also in the next step going to bring that over. So right now I have 2 cosine x, I guess I'll leave this for a moment, plus root 3 equals 0. Now, if it was quadratic or anything bigger than first degree, so second degree, third degree, so on, 90% of the time you want to get it equal to 0 and try to factor, but let's go from here. Since it's essentially linear, you could think of it as linear, we could just go ahead and solve. So I'm going to subtract root 3 from both sides. Think of linear as like a prime polynomial. It is already factored. There's nothing else I can do. So I have 2 cosine x equals negative root 3, and then I'm going to divide both sides by 2. Now, if this 2 is inside with the x, you cannot divide by it. Okay? No, not until you get rid of the cosine. And that requires either you mentally doing the inverse operation or you actually on paper doing the inverse operation. So right now we have that cosine of x allegedly equals negative root 3 over 2. So that's where we are right now. Let me get more scrap paper. Now, I'm not going to write down cosine inverse right now, okay? I'm going to keep it a little light. But from here, you're going to ask yourself the magic question, okay? You're going to ask yourself the cosine of what angle is equal to negative root 3 over 2? That is the question you're going to have to answer for yourself right now. The cosine of what angle, and this is the what angle, x, is equal to negative root 3 over 2. Now, cosine is the x value. Negative root 3 over 2 means negative direction, so that means we're going left that way. And it goes left a lot. So if you kind of picture the circle, which angles are associated with us going left a lot? What angles are we looking at? Now, if you said when x equals, that would be 5 pi over 6. And when x equals 7 pi over 6, then you would be correct. Okay? So you can write your answers like this, or you can write your answers in set notation where you kind of just list them. I try to always list them in order from least to greatest. And you would get 5 pi over 6 and 7 pi over 6 in these little cute curly brackets. You could do it like that. It's a little bit nicer. And there you go. That's it. Okay, now let's just show you a little visual demonstration so that you can understand what would happen if it was, say, cosine of 4x equals negative root 3 over 2 or something to that effect. Like, how would that change things? So let's show you what I've prepared. We have, Desmos is right here on your screen right now. So when you solve systems of equations, this side equals this side, you could basically graph each thing. So if you see the first line, I wrote y equals cosine x. So if I graph that, even though maybe you didn't learn how to graph cosine yet, if I graph that, it's going to look like that. I just turned that on right there. It's the red graph. And if you look at it really, like, this is cosine of 0. The answer is 1, where I'm clicking. Maybe if I click on the right thing. Clicking right there. What's the cosine of pi over 2? It's 0. What's the cosine of pi? It's -1. What's the cosine of 3 pi over 2? It's 0. And what's the cosine of 2 pi? It is 1. Now this wave goes on indefinitely in both directions, oscillating up and down, up and down, up and down between 1 and -1. Now y equals radical 3 over 2. I want negative though. So let's go over here and we're going to add in our negative before I turn it on. So negative root 3 over 2, if you even see, it's negative 0.86. So it's going to be, if this is -1, 2 boxes down, right? Then it's going to be, you know, between the first and second box. So let's turn on that graph. There it is in blue. Okay. So if I hover and click, there's the 5 pi over 6, and it's a little funky when I clicked on it, but that's 5 pi over 6 that I'm clicking on. It's popping up to the right, and there's 7 pi over 6 that's popping up to the left. I don't know. Not the cutest, okay? But whatever. Those are the answers. That's where they intersect. That's where they're equal, but we can do that with our brain and the idea of the unit circle, right? Now, if we only want answers between 0 and 2 pi, 0, I just graphed it in green. That's 0 right there. And 2 pi, I just graphed it in purple. So it's like saying, I only want the answers between this and this. Now, why, you might say, why would I only want the answers between there and there? If I zoom out, you're going to see I have an infinite number of graphs going forever and ever, right? So 0 is where the green is. This is my y-axis. And I'm only looking for the answers between that and the purple, 2 pi. And if I go back over here and click on my graph again, there it is, 5 pi over 6 and 7 pi over 6 for my answers. Now, if I go over here in front of the x, okay, and I'm going to type in, for now, I'm going to call it b. If I put in a value b. Now, my graph went away because I have to decide, am I going to add a slider? And that slider is me changing the value of b. So by default, b is 1, and I'm back to where I was just a few seconds ago, okay? So I'm going to play with the slider. As I increase b, b is going to basically do what we call a horizontal stretch or compression. As b gets bigger, you see your graph compress closer and closer to that green line. So when b equals, say, 2, how many complete waves do we have between the green and the purple? If I start there, go down to the bottom, work my way to the top, there's the 1 complete wave, whoop, whoop, going down, back up. And then if I go down and back up again, I'm accidentally zooming in, sorry, I will go from there to there, and that's another complete wave. So when I made b equal 2, I ended up having 2 full graphs squeezed in between there. Did my height change? No, it's still 1, okay? Now, if I make the b value bigger, so I'm going to use the slider so you could like watch the b value change. So as b gets bigger, squishing, 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 3. If you count, I promise you have 3 complete waves between 0 and 2 pi. Well, now how many times does my blue line intersect my red graph? Let's zoom in a smidge. I got 1, 2 right there, 3, 4 right there, and 5, 6 right there, okay? I have 6 answers now. And what were their denominators? They were all 18, okay? So it's like they started off with a 6. If you divide by 3, that's really times a third. That's where that 18 comes from. Back when the b value was 2, right? I have 2 full waves, and my 2 answers turned into 4 answers. They have a denominator of 12, okay? Where did these answers come from? Again, if I slide it back to 1, these points over here, the 17 pi over 6 and the 19 pi over 6, those answers are the ones that as b gets bigger, they squish in and become answers. When b becomes 3, when b becomes 4, I keep pulling in the next hump of answers. Okay, so I'm squishing them in. So I need to find the next answers and then scale them down with the squish as well, that horizontal compression. So that's a mini lesson on why we do what we do. So let me hide that again. Okay, so if that were the case and I had this situation, which we don't, but we're going to make believe, then you start off the same way, 4x equals, so cosine of what angle? equals negative root 3 over 2. You would still say 5 pi over 6. But now I'm going to make a mention that it's plus 2 pi n. That means plus 2 pi n 0 times, plus 2 pi n 1 time, 2 times, 3 times. I could keep adding it over and over. And then the other is plus 4x equals, not plus, 4x equals, the other answer, 7 pi over 6, also plus 2 pi n. From here, I'm going to divide everything by 4. By 4, by 4. That means I have x equals, dividing by 4 is multiplying by 1/4, so that becomes 5 pi over 24, plus, now it's 2 pi over 4, let's get a common denom, that's 12 pi over 24. And then here, I'll get x equals 7 pi over 24, plus again, that 2 pi, 12 pi over 24. What's wrong with me? Hello, 48. Sorry. Sorry, caught it. Good thing. You're almost about to yell at me in the comment. All right, so it says 48. Sorry. All right, so plus 48 pi over 24, that's 2 pi. Then, oh no, I was right because it's not 2 pi. I was right. Hello, because it's 2 pi over 4, that is 12. I need more caffeine. I'm tired. Okay, so I want to list my answers. What's the smallest answer going to be? It's going to be the 5 pi over 24. That's my starter, right? Comma. Next, I have 7 pi over 24. Those were my first two. OGs just being squished. Next, the one that came after 5 pi over 24, if I added 2 pi and squished, or squished and added the new amount, is 5 plus 12. That would be 17 pi over 24. Then the 7 pi over 24, the next answer, if I added the 2 pi and then squished, or if I squished and then added the new amount, 7 plus 12 gives me 19. 19 pi over 24, and I just keep going. If I go back and forth, it just keeps the answers in order from least to greatest. So I just keep adding 12. 17 plus 12, 29 pi over 24. 19 plus 12, 19, 29, 31 pi over 24. How do you know when to stop? We want our answers by the directions. We want the answers between 0 and 2 pi. So that means I'll stop when I get to like 48 pi over 24, because that's 2 pi. That was 29 plus 12, 29, 39, 41. That's not 48 yet. 31, 41, 42, 43. 43 pi over 24. Shoop. Oops. Ugh, get on the screen. Okay. And there you go. So that's what you would do in that situation. Okay, so what that did is it squished everything all together, right? Squished, compressed, whatever. So if I just go back here, okay, so whatever, those were the answers. I guess I could leave them on. Sorry. Get over here. Okay, I'll leave them down there. And then if we look at our answers, I got, there's 5 pi over 24, 7 pi over 24. Got those. Next two, 17, 19. Can you see that? Yeah. Then I have 29, right? And 31. Then 41 and 43. The next one, that was the 2 pi line, would be, hold on. That would be the next one, and it would be 53, I believe. Yeah, 53 pi over 24, which is more than 48, and the purple line is 2 pi anyway, so it's over that line. So that is why and when we put plus 2 pi n. So I hope this clarified it a little bit for you. I'm going to keep doing more examples as they are in this particular packet of examples. So check the playlist for more examples. You could jump around, try to find the one that has, a setup like you'd like more help with, or you could just put a direct comment in the comment section. As long as I'm still recording, I will interrupt and do your specific request. Okay? Okay. Thumbs up if you enjoyed, and if not, put a thumbs down or whatever you want to do. All right. Where is the stop button? I have too many windows open. All right. Bye for now.